as the chief guest at the event. I also would like to extend my thanks to Professor Gilbert, Iowa State University, who accepted my invitation to participate in this event as our resource person. I would like to briefly introduce Professor Stephen in front of you with his biodata. Professor Gilbert has done his PhD in Brain and Cognitive Sciences from MIT, USA. He is working as an Associate Director of Iowa State University and Director of its Human Computer Interaction Graduate Program. He is also Associate Professor in the Industrial and Manufacturing Systems Engineering Department. His research interest focuses on technology to advance cognition, human autonomy, teaming, and XR cyber sickness. He works closely with industry, the US National Science Foundation, and the US Department of Defense on research contracts. He has also worked in commercial software development and run his own startup company. In his credit, there are total 63 funded research projects that are ranging from different Department of Defense, and in the overall it is contributing to 42%, National Science Foundation about 26%, Boeing 7%, John Deere 3%, and others around 22%. So his total project grants which he received over the period of time is 25 million US dollars of this total amount of the funded research. Also, the work which he did with John Deere, he received 2 patents from that. Okay, so this is about the brief introduction about our guest of honor. Okay, now as far as the course which you are going to attend is concerned, so this particular course, as you can see, so there are 2 different parts: cognitive engineering and human factors. So cognitive engineering, basically referred as the cognitive ergonomics, focuses on optimizing mental interactions between the users and the technical system. So most theoretical things, just with example I want to brief about this, why this cognitive engineering and ergonomics is important. So this engineering in the development of any system, the engineering and design moves together. So whatever or extent we take to design the system with any kind of engineering, so there is always the requirement of the design is there. So from the designer perspective, if we are not designing a particular system in a better, or interactions we are not designing, so there will be some kind of cognitive loads will arise. So that analysis, mental attention, the memory, how we are focusing, that are the parts which are covered in this cognitive engineering. If I will take the example of the projector screen which we are having in front of us, so this is a one design or one system which has been designed, motorized, okay, but there are some part of the designs are there that when we were installing, so we observed that there is some design flaws are there, okay. So there are some tingle in that wire and the arrangement which they have made, so that from the designer's perspective has not been considered, although it is perfectly working, okay. So we will discuss later on. So there, what I want to say here is that always there is a involvement of designer is there when we are designing any interface for any system. Okay, so this is about the brief about the cognitive things. Human factors, we all know that anatomical, biomechanical postures analysis of the human body that is required to carry out or perform any task in its fullest way or with greater efficiency and productivity. So these are the 2 key parameters that are not being addressed or given importance in most of the research institutes, but the NIT Rourkela is having the unique that it is the only NIT which offers this design department across all the NITs. So with this short introduction about the course, now I move to the registered participants. So we got we received a good number of participations from the UG, PG and PhD levels. Also we have some faculties from different deemed universities and participants from different IITs. Also we have the participation from industries as well as the medical center, that is the AIIMS Delhi. Regarding the lectures, so this 5-day course will be having a total of 12 lectures and 5 tutorials followed by an examination. As the course coordinator, I hope and assure all the participants will get enough knowledge and scope for further research in this area. I wish you all a comfortable stay at NIT Rourkela campus. Thank you all.
Thank you, sir, for sharing your insight. Now, I would like to invite GIAN coordinator, Professor S.K. Sahu, sir, Professor in Civil Engineering Department, NIT Rourkela. He has published 69 papers in research publication in referred journals. He had received UKERI British Council Fellowship for postdoctoral studies in ISVR Southampton University in UK. I request sir to address the gathering.
A very good morning to all and welcome to the GIAN course, Cognitive Engineering and Human Factors. Respected Director, NIT Rourkela, the foreign expert of the GIAN course, Professor Stephen V. Gilbert, Head of Department of ID, Course Coordinator, Dr. Mohit Lal, dear faculty colleagues, participants, students, ladies and gentlemen. Professor Mohit Lal has done, I think, 2 courses before. Human vibration, right? On human vibration. Similarly, this is also like related to that area also. GIAN is a Sanskrit word means knowledge. GIAN full form is Global Initiative of Academic Networks, is a program of the Ministry of Education, Government of India, designed to tap the talent pool of scientists and entrepreneurs internationally to encourage their engagement with the institutes of higher education in India to augment the country's existing academic resources, accelerate the pace of quality reform, and elevate India's scientific and technological capacity to global excellence. GIAN enables institutes of higher education of India to invite and host internationally renowned academicians and researchers, facilitating the co-teaching of advanced courses to Indian students and faculties, and fostering collaborative relationship with experts from around the world. So this offers a unique opportunity to familiarize the international experts with India's academic environment. By interacting with local students and faculty, experts can explore potential collaborations, share their expertise, and contribute to the advancement of knowledge across diverse fields. Cognitive engineering, and human factors are interconnected fields. Like Aziz, the coordinator says, it is basically to design something which will be human system compatible, more efficiency, to like layout of a cockpit of a airplane for convenience of pilot, control room for good management. Similarly, any system can be designed more human friendly. So that's the basics of the engineering. The exact tools and all those things will be discussed by the expert. So NIT Rourkela has already conducted 12th course in this season and ready to conduct 2 more courses in the phase. All best wishes to the persons involved in making the course a success. Thank you very much.
Thank you, sir, for sharing your thoughts. Now, I would like to invite the in-charge head of the department, a member of the Acoustic Society of India, respected Dr. Divya Prakash Jaina, sir, to present the goals and objective of our department.
Good morning, everyone. I welcome Stephen and Professor Umamaheshwar Rao, sir, our Honorable Director, sir, and S.K. Sahu, sir, who is coordinator of GIAN course, and Professor Mohit, who is conducting this course that's on human factors and cognitive engineering. So, about the department, our department is around 1.5 decade, and we are we are the almost the youngest department in NIT and the smallest, but however, it is sometimes our pleasure and proud moments to tell that our students scored that highest package in terms of performance, or our department scored the highest number of projects. So this year there is a good news that ID's department scored 1.2 CR. I think almost the highest package of the institute was cracked by the industrial design department, right? How many of you know this? You didn't know? Okay, last week your senior, the final year student, cracked 1.2 CR package, that is the highest in the institute, with the Rubik's. So we are small, we are not big like our neighbor, but we are smart. And yeah, the best part is the HOD of mechanical, Professor Patel sir also is here. It's the right moment to tell how we are different than them. So I will tell you a very single line: we design for human. We design for human, right? In all our design classes, I always tell we design for human, right? We don't design soft, we don't design turbo generator, we don't design, but we design for human. And that's how this cognitive engineering and human factors are highly important. And it's a it becomes so important after particularly the COVID, because of the digital world, and now the language of cognitive engineering and human factors are changing to address the issues we are getting from the digital world. Anyway, those things will be taken care of by the Professor Stephen Gilbert, and I think he will definitely address all these points during his lectures. So here I'm not taking much time. So that's about our department. I think everybody knows, and we have lot of openings. So I request you please share across the other universities that we are looking forward the prospective faculties. We require the prospective research scholars. We require the prospective master students, etc. So here I am concluding my talk. Thank you.
Thank you, sir, for sharing your insights. With all due respect, we have Professor Stephen B. Gilbert, who is currently working as an Associate Director of Iowa State University and Director of its Human Interaction Graduate Program. He has been the PI and co-PI on 63 funded research projects sponsored by the Department of Defense. He is chair of a Human Factor and Ergonomics Society HFES technical group on cognitive engineering and decision making. He worked closely with industries, the US National Science Foundation, and the US Department of Defense on research contracts. His area of specialization are technology to advance cognition, human autonomy teaming, and extended reality cyber sickness. I request sir to acquaint the audience with a few words.
Yeah, if you like. Test, test. Is that good? Thank you so much. I'm really grateful to be here. I have to thank Prof. Sahu and Yena and Rao for participating and getting me here, and most of all, Prof. Lal, who has spent endless time with me on WhatsApp to convey to me how to get here and what to make out of this course, and I'm so grateful to be here. It is my first trip to India, and I'm loving it so far. The food especially. Okay, so cognitive engineering, we know how to fix machines usually pretty well, right? The machine breaks and we go in and we add a little oil here and we tighten a bolt here. And if you get in a bad relationship with a friend at work or a friend at home or your romantic partner, sometimes you don't know how to fix it, right? Human beings are so much more complicated. And you wish, oh, it were so easy to fix, like at work with the machine and the oil. I could just, this team is so dysfunctional. Can't I just add a little oil, right? But you can't. It's more complicated. And so because humans are one of the most complicated sort of systems out there, that's why we have cognitive engineering. And so many of the cognitive engineering applications are stressed out groups of teams. So in a hospital emergency room, You know, what can you do to add technology to a hospital emergency room so people make fewer mistakes, so that people will have better patient outcomes, or in air traffic control, or in disaster recovery. Here has been an earthquake or a tornado. Where I come from in Iowa, it is always tornadoes. And then the houses are sort of smashed, and you're wondering, are there people underneath the ruins? And they send dogs, and they send robots maybe. And so what can we do to have those people collaborate better? So when you're a stressed out group. So this is such an important topic. And it can only be really done successfully when you get together the engineers and the designers. And so I was so excited to hear, as they gave me a tour of this building, about, well, these are the engineers and these are the designers, and we're coming together in its industrial design. I thought, well, this is the perfect team to solve these problems. So you're in such a great position. And I hope that over the next week, if you volunteered to tolerate me as a lecturer, then I hope you will learn a lot. And you will end up knowing how to analyze situations, and you will see even the human situations, and you will have a toolbox of tools that you can draw on. So instead of the oil and the screwdriver and the wrench, you will say, this situation needs cognitive task analysis, or this situation needs an affective design. And then these are some tools you will have at your disposal to try to address these problems. I think that's enough for now, because I'll be talking at you a lot more later. Thank you.
Thank you for joining us today in the inaugural ceremony. Your words were inspiring. With all due respect, I invite Dr. K. Umamaheshwar Rao, sir, Director, NIT Rourkela. His contribution and dedication to our institution need no introduction. Dr. Rao has done many exceptional work.
I think this will be. I'm presuming that you know me, so I don't need any introduction. Having said that one, the dignitaries on dais, we have Professor Stephen Gilbert from Iowa University as our distinguished guest of honor, and Professor Sahu, and Professor Jaina, and then Professor Mohit Lal, Professor Saroj Patel, and other faculty, Rajiv Khan, and other faculty members of various departments. And it gives me immense pleasure. In fact, I was just only trying to know from my secretary that it's a long time that we have really shared our GIAN. Right. So now, I just would like to really ask Professor Sahu that why, since a long time, there is a break, a lull in the GIAN programs at NIT Rourkela. In fact, for the information of all of you, NIT Rourkela is one institution which is really offering many GIAN programs. That means we are sharing a lot of GIAN to remove the ajnan from our thoughts and feelings. Having said this one, this is one very beautiful topic. Cognitive skills, or that very word itself is self-explanatory, cognitive skills. Engineering is another one. Okay, and the last is human factor. So now whoever has coined this one, they have put everything together, right? Engineering, and then the cognitive skills, and in that one, our human factor. Okay. Before we really go into what Jaina has stated, that he has stated many remarks which I refute everything. Right? He said that we design for human. Design is there in the nature. Right? If you eliminate ourselves from the nature and then take this supremacy over the nature, and you have lost your existence, and then realize the beauties of this design and symmetry which is already existing in the nature. The very galaxy in which we are, did any human design the galaxy? The planetary movement and the balance and the symmetry, and with which for millions and billions of years the system is on. There is no human element in that. Is it there? It's not there. I will take the simpler examples of that. You must have seen in another month or two. If you have not seen, you please try to watch the nature which is there on campus around you. This is the time when you find Lots of butterflies in the campus. Lots of butterflies. I'm not talking about the design of butterfly flying in the gardens. But then they leave a caterpillar. The caterpillar is stuck to the bottom of a leaf. Okay? And then over a period of time, this caterpillar stuck to the leaf turns out to be a pupa. You just look at that particular pupa, the intricate design of that one. Did you design? We did not design. If you just intensely take the design of that particular pupa under the leaf, there is so much of cognitive skills the butterfly, the little butterfly had in selecting that particular leaf or any leaf, okay, or a branch. It doesn't take the branch, it takes only leaf. It selects the leaves in such a fashion that no andi, no tufan, no matter whatever be that is there, it is not going to disturb that particular pupa. And then the pupa is absolutely symmetric. Don't take the credit of the design of the pupa, that it is human design. 2. And then again a month later, September or October, you go around the campus and try to see, this is one campus which is really a beautiful campus, and then you find so many different varieties of spiders. They are not harmful spiders. These are not tarantulas. Okay, these are not tarantulas. They are as big as my palm. All right. You just look at the symmetry that is there in the design of the spider's web. That design has a purpose. That design has a symmetry. The design sustains the rain. That design sustains the mist. That design sustains the wind. Who designed? Jena? Then who designed that one? Nature. Only thing is that I want the industrial design department should become a part of the nature. That don't say that human beings are above the nature. Right? Last, I tell you, the last. There are so many such examples which are there around you, whether you have noticed or whether you have not noticed. If you have not noticed, I just want you to notice that one. Okay? The bird's nest. The bird's nest. You must have seen in many pictures, there are different varieties of nests. Many varieties. Sparrows, they design the nest in such a fashion that it is really having a small pouch in that one, and this is hanging down the leaf or a branch just above the water body. There is so much of cognitive skill really gone into the design of that one. No snake should really be crawling there about that branch and trying to really go into the nest. In the process of that one, it slips and then falls into the water. This is the beauty of a small canary bird. It is as big as this, a sparrow. It makes such a beautiful design. Only difference between the other existence in the nature and then human beings is that we take the credit and we take the claim. They don't do that. We say that we design for human. They design for existence. There is a lot of difference in these two. Taking the supremacy of that we are designing, the very purpose of design is defeated. This is one thing which you have got to really design about. Think about it. Yes, there is no design without symmetry. Yes? Agree? Sometimes we try to really create asymmetric designs also, particularly in mechanical, when we really try to really have a reciprocating motion to that one, we try to really make a asymmetric designs. Okay? In our Indian knowledge system, the best depiction of duality and then the design, perfect symmetry of existence and of destruction is Shivatandava, Nataraj. Right? It is there. It has been there in our knowledge system. Okay? That design is one thing which is really there, imbibed in our thoughts and various other the features that we are really creating that one. The temple architecture itself is something which is unique. And the beauty of this temple architecture is that in southern India, temple architecture is different. Within South India, Andhra and Telangana, they have a different temple architecture. You go down to Madurai, they have a different temple architecture. You come to Karnataka, mid Karnataka, right, Harappa, not Harappa, this is Halibeg, Belur and Halibeg. Okay, you come to western side, there is a different architecture. In the eastern side, there is a different architecture. None in the past in our history, they really took a claim that we are supreme and then we are designing. The designers were killed by the kings so that the similar design is not really replicated anywhere else. This design is the power of mind. It's a design is the power of mind and it is the mantra of existence. This you have to understand. And industrial design department cannot, coexisting with mechanical department cannot stage that we are different. You have lost the purpose. If you alienate yourself from other engineering departments, you have completely lost your purpose. You should be the part of the engineering education at NIT Rourkela. This is other thing which I want to say that I am different in my views about what Professor Jena thinks about. And life is not measured. Happiness is not measured. Living in bliss or living in ecstasy is not measured by what is your CGPA. Is it measured by that? Child looking at her mother, a child, months old child, 12 months or 13 months old child, left in a day school, okay, left in a day school, and then if the child listens to the voice of her mother calling her name, there is bliss and ecstasy in her eyes and the movements and acceptance. There is no JE that this child has passed to be happy and achieve and claim that, yes, behind this happiness or ecstasy, there is one exam which I have passed. No. To be living as a human, you don't have to have a JE examination or credits or to the example that 1.25 crore CTC. No. Will that give you happiness or will that give you arrogance? What will it give you? Why should that be a part in our existence that I have cracked JE, my CGPA is this much, and then my package is this much? You take pleasure out of describing that someone is less than you. Is it a perfect design of existence? No bird, no spider works towards the destruction of the other bird. They may be predators for insects, but then they don't try to, a bird does not eat another bird. The tragedy today we have is that we have defined ourselves supreme. We have defined ourselves supreme above the galaxy or above anything, universe. And I today would like to demean you or disintegrate the rhythm in the existence. To the extent that geopolitical things which are happening around, Donald Trump makes a claim or a comment. Right? We are silent. I'm not going into that particular thing. It's just only expression of authority, arrogance, and egoism. That is this the design, the cognitive skills that we need to have? Or is it the one which is defining our human factor? What is it? If we are existing where we have the ability to think more than a canary bird or a sparrow, it becomes imperative that we have to protect this planet. That is the best cognitive engineering that we have got to do. With these few words, my dear students of industrial design, you are a part of this human skeleton. If this human skeleton is existence, defines the existence, there cannot be any best example of the nature's design. It is the human skeleton. Right? Perfect balance. If you just watch any of the, I end up with my one comments about the cricket. If you try to really watch the bowler bowling at the time of releasing the ball at 145 kilometers per hour, there is so much of balance on his toes. The whole body is like this, but then he is balancing on the toes. Can you design any machine like that? A dynamic. This is all a part of the nature which has given us so many skills, with so many bones and joints, whatnot. The very human body itself is a challenge for you to understand what exactly is the beauty of a design. Thank you very much for giving me this opportunity. And then I have just been really because I am the head of this institution, Professor Stephen. I cannot say that industrial design is superior, and then I cannot say that mechanical department is inferior. No, you have to be a part of that one. खिचड़ी में जब खिचड़ी पका जाता है, खिचड़ी में करिया पत्ता भी important है ना? Enjoy that one. Being a human is a beautiful opportunity because we can express our feelings. Everything. Right now what I am doing is that. I am expressing my feelings. Right? No animal, whatever be, how skilled it is, it cannot really voice the inner feelings. We do it. So, हमें एक और दायित्व है. We should not lose our अस्तित्व. You understand the word अस्तित्व? अगर आप अस्तित्व को दफनाएंगे, you are lost in that. Thank you.
For sharing your deep knowledge with us. Your words were full of enthusiasm and valuable knowledge. On behalf of the organizing committee, we express our deepest gratitude and take immense pride in felicitating our guests with this small token of appreciation. I request Director Sir to felicitate Professor Stephen B. Gilbert.
Yes, miss. It's a black box. अब क्या दिया है मुझे समझ में नहीं आता. Now Professor Stephen also knows.
Okay.
So we welcome you again to a beautiful and wonderful campus.
Thank you.
It's hot and humid, but then within that there is a beauty in that. Chill.
Now, I request GIAN coordinator, Professor S.K. Sahu sir, to felicitate our beloved director sir.
थैंक यू. ज्ञान प्रोग्राम का देख लीजिएगा, बहुत कम हो गया यार. चलो.
I request HOD in charge, T.P. Jaina sir, to felicitate Professor S.K. Sahu sir. Now, I request Mohit Lal sir to felicitate Professor T.P. Jaina sir. the vote of thanks.
Thank you, Vishaka. Once again, very good morning to one and all. As the coordinator of this 5 days short-term course on cognitive engineering and human factors, it is my privilege to deliver the vote of thanks. First of all, I extend my heartfelt gratitude to our esteemed chief guest for his gracing us his presence and sharing invaluable insights and telling us the difference between the design and engineering and how we should associate with the other engineering branches and in which particular direction we should focus and work together. Sir, your words have inspired and motivated us as well as guided us. Thank you for that talk. A special thanks to our resource person, Professor Gilbert, for brief introduction about the course and highlighting the relevance and significance of this cognitive engineering course. I am truly grateful to the Ministry of Education, GIAN scheme, IIT Hyderabad for considering our course proposal and providing us the financial support. I am deeply grateful to the Institute Administration, especially the Registrar Office, SRIC and Finance Office for providing us the necessary resources and support. Thank you all the participants and attendees for being part of this workshop. Your involvement, the questions in the upcoming sessions and insights will definitely add great value to this event. Last but not the least, I am grateful to my industrial design family, my fellow colleagues, with special thanks to Dr. Rohit for his help throughout the preparation of this course, laboratory staff and student volunteers for their suggestions, hard work and dedications in helping to organize and manage the inaugural event so efficiently. Your support made a big difference. I extend my thanks to each and everyone who directly or indirectly support us in making this event successful. Thank you all.
Thank you, sir, for delivering such a wonderful vote of thanks. With this, we have come to the end of inaugural session. Once again, I would like to thank each and every one of for your valuable presence. I request everyone to please stand for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Was that?
Yes.
If we were in a church, I would
Participant can go and take the tea and everything. It's arranged outside. Volunteer, please help them.
Thank you for coming all the way to here. Thank you.
absolutely. You're department head of department for mechanical. Lovely, lovely. More like here. Well, let me see. Is that good? Okay. I'm going to move that there. And I get, is this my water or somebody else's water? This is mine? Hello. Okay.
Everything fine?
Yes. I wanted to ask how long you want me to go because, you know, I was going to have 2 hours of two different lectures before lunch, but now it's.
So it's up to you. Like already the next time 15 minutes was there, so that we have already done, right? So in stage, if possible, 1.5 hours, is it possible?
Yeah, 1.5?
Yeah.
Yeah.
The rest portion you can start after post lunch.
Yeah.
Then from there you can continue this tutorial.
Yeah.
Yeah.
That's
So,
fine.
Half of this portion you can club now.
Yeah. That's
Or
good.
you can extend up to 12:30. That is fine.
Okay.
11 to 12:30.
Okay.
Then half an hour you can club here.
Okay. Good. I'll stop at 12:30. That sounds good. Yeah. So I think I'm still waiting to go, right? Should I go or should I wait? Which? We're ready? Okay. I think we're ready. So I am Stephen Gilbert, as you heard earlier. So I wanted to start by talking about, can you hear me okay with the fans? Yeah, you're good? Okay. So I have a video for you of a Spanish train crash. And I'm hoping you will imagine you were an engineer assigned to deal with this.
Security camera footage has emerged of the moment the Spanish train left the tracks near Santiago de Compostela in what is being described as one of the country's worst rail disasters. 78 people are now confirmed dead, with 131 injured, 20 of those seriously.
Okay, I'll stop there. So this is a train, right? It's going too fast on a curve. It flips over. So if you are part of the Spanish Transit Authority and they say, oh, why do I have no things? Is it back? Yeah, it's back. Then see if you can fiddle with wires or something. I don't know. But then what questions would you ask? What are you're going to play detective and figure out what happened. So what are some questions you might ask about this situation?
Why did the train crash? Why does it flip?
Why does it flip? Yeah, and okay, yeah. And then what are you going to do to figure out why it flips?
What was the driver doing?
What was the driver doing? Okay, that's a driver question. Maybe you think it's a human problem. Okay, what other sorts of problems might it be?
What was the train speed?
What was the speed currently? That's right. And I think I've got it on my next slide, I think, but it's maybe 175 kilometers an hour, like pretty fast, right? So the speed, so if you're worried about the speed, you're like, how do we get this fast? What else might you need to ask?
The curvature of the car.
Sorry, say again?
What about the curvature of the car?
What about the curve? Maybe it was too strong a curve. This train was not built for this curve. Maybe it shouldn't go on that curve, that sort of thing. Anything else you can think of? Why did the system not override it? Right, a lot of these trains, the high-speed trains, have the override system that'll break it and make it stop. That's right. Why didn't that work? So we've got some, system questions. Like we had the human question, like what was the driver doing? And then we had a question about the system, and then the infrastructure, like the track. And there could be maintenance questions. They're like, oh, maybe somebody hasn't maintained it. A variety of things, right? So these are all the pieces, right? And you have to, and often, I don't know if you've come across root cause analysis. Has anybody heard of root cause analysis? This is where you're asking why. And one of my instructors said, you basically ask why like 5 times. why? And you say, why? Well, because of this. Well, why is that? And why? And you keep asking. And it sounds a little aggressive, but you get often down to some causes you might not have thought of. Because when you're an engineer, sometimes it's hard to figure out which problem you're actually solving. So you have to do this detective work to figure out, well, was it the human train driver or not? So it turns out that trains have black boxes just like airplanes. And in Spain, there's rural train routes that are high speed, and there's city train routes that are not as high speed. And each of the systems has a regulation, like Ria was talking about, and that is going to cap the speed. But it was right on the border between rural and urban, so the systems didn't cope. The systems weren't talking to each other, and they hadn't planned for that. And so when they listened to the black box, the conductor was on the phone with another crew member, basically asking, where are we? He had forgotten, he had lost track of where the train was, and he knew that they were going to enter urban situation. They had to slow down at some point, but he had lost the timing. And what's also interesting in the background of the recording is you can hear two different alert systems going off, like, And so that meant that this driver was so focused on the situation and panicked that these really loud alert systems were not helping. And that's where the cognitive engineering comes in, right? That's why if you were designing that cockpit, somebody says, you must design the perfect cockpit that no driver will ever crash this train. Like, what are you going to do if two loud alerts are not working? Maybe you need an electric shock belt. I don't know. What are you going to do, right? So that they will shake them out of the tunnel vision and the panic. How are we doing?
Can we use this laptop?
So what do you think the problem is?
Actually, sir, I'm not acquainted with the macros and all.
Oh.
It's not giving the HDMI output properly.
Huh. Let's just try let's try this over here.
Okay.
So one moment while we sort out the technology. I mean, we could try to move the file over, but it should be pretty easy. I have another HDMI cable in my backpack too, if that's helpful. Like, you don't think it's the cable?
So this one is a cable?
I don't know. Do you think it's the cable? This is getting good signal. I'm a little puzzled why it's not like logging in. Okay, so now, are we getting signal? Now we're good. Okay, so, by the way, in this course this week, what I've done is I made a Google Drive folder with the outline of the course, and it's going to have everything you see. And every time I reference a reading, that reading will be a PDF in the folder, so you can download the articles or the slides and click these links. So you think we should switch then? I don't know why. I'm not. Sorry?
If you can mail me the PPT, I will connect my laptop.
Yeah, okay. So we're gonna try to transfer this.
If it is in this USB, then you can connect it directly to me.
So should I try a USB drive or should we try mail?
Whatever is.
Okay, what's your email? You want to type it? Actually, I should get a USB drive because my next file is too big. Phone in the car, because you need more resources to do that. It's not so good to talk to your grandmother who maybe is mad at you about something, right? Like, emotions are going to take up some attention resources, so try to save those and drive better. Okay, how many people have seen this basketball video? Has anybody seen the basketball? Okay, so so don't say anything too much. We're going to watch this video. Let's see if it works. Can I get on the internet with this? Can I just launch it? See if you can get it to play. Oh, now it's spinning. Maybe. It is coming, so is it going to switch on the screen to this?
The monkey business.
Okay. Yeah, good. And we can full screen it.
Count how many times the players wearing white pass the ball.
Okay, so do this. There's watch for the players in white. Count how many times they pass the ball. There's a ball. Players in white. Count the players.
The correct answer is 16 passes.
Okay, how many people got that? Okay, so a lot of people got it. That's good. How many people noticed the gorilla? Anybody notice a gorilla? And some people are like, what? So, yeah.
Did you spot the gorilla? For people who haven't seen or heard about a video like this before, about half missed the gorilla. If you knew about the gorilla, you probably saw it.
So the system 2 is. There's this famous study, and they walk you in a room and they say, here's a number. I want you to memorize this number, and then walk down the hall and tell it to the person at the other end of the long hall. And so you're having to walk down the hall like 257, 257, 257. And some people, they give a 3-digit number, and some people, they give a 12-digit number, right? It's really hard. And everybody, they're walking down the hall, and they have this attractive woman come out with snack chocolate cake or a healthy fruit dish. And she'll say, would you like a snack down your hallway, down the hallway, you know? And the interesting thing is that the people with the 12-digit number choose the cake more. And this is the issue. The assumption is that your brain sees the cake and it's like, I want the cake. You know, the primitive system 1 is like, I want the cake. And the system 2 might be like, the fruit is healthier. You should have the fruit. But the system 1's like, I want the cake. So if your system 2 is occupied with a 12-digit number, it's gone. Like when it comes to the cake fruit decision, it's occupied, it's busy, it's not helping you. So your intelligent Homo sapiens part of your brain can be overridden by a cake, right? So this is a little scary. What this means is that if you're making decisions in the future, like what job you're going to take, whom you're going to marry, you know, whether to leave, you know, I don't know, big life decisions, right? You don't want to be handicapped by tiredness, fatigue, emotion, being drunk, you know, like you need to have all your system 2 ready, right? So that's sort of a caution. And this is a caution for your users too. If your users are working in a factory and maybe they're going to be fatigued or tired, you need to make sure they're not using system 2 a lot. Okay, so let's think about some design issues that come from this. And some of the optional readings I've got out there, we'll talk more about this. But we talked about the train conductor. These alerts are going off and he's not hearing them. So, you know, how are we going to do alerts? And there's some basic design principles. Is the alert really salient? Is it different than the background? Is it expected? Like, has somebody trained them? Like, when you hear this alert, it means this. Is it foveal? So in our eyes, we have the fovea, which is a really narrow center of your view, and that's the highest resolution part of your eye. And you can try this with a friend later, if you want. If you go and get like a colored object, like you have crayons or pens that are different colors. Here's a pen. And maybe it can be a red pen or a blue pen. And you have a friend stand behind you and slowly bring it forward. You look straight and slowly bring it forward. There's a point in your vision when you can see there's a pen and you don't know what color it is, which is a little weird because your cones are in the middle of your eye with the high resolution. The rods are out on the side, and they just know about, you know, is something out there. They're black and white. The cones are black and white. So if it's a color, you won't know what color the pin is, even though you can see it's a pin. So you can try that if you want. The other great thing is that we are so visual that if you can get alerts to be auditory or tactile, then it's better because it's not taking up that bandwidth, right? I'm focusing with my eyes on where to drive this car that's maybe swerving, and if I can have alerts that are auditory or buzzing me, a lot of now the extra safe cars, like I was driving a rental car recently, so it was a brand new car, and it had these vibrating parts under my bottom. You know, I'm driving and it's like when I'm backing up, if I'm getting too close to the car behind me, it's like, and it's backing up the back of the seat. So it's doing all these things that are different sensory modalities. Okay. Oh yeah, and banner ads on the web are a good example of how to get your attention too, right? Because they know how our visual system works. They know that jitter is a popular thing. So we have neurons in our brain tuned just for detecting jitter and just for detecting rotation. So you'll see like spirally things or jittering things. The arrangement of the display, right? So if I have 6 features of my smart home and I want to adjust the power or the alarm system or something like that, am I gonna arrange them alphabetically? Am I gonna arrange them based on how frequently I use them? Am I gonna arrange them based on, like what would I arrange them by, right? So there's different decisions you have. And you typically wanna group them by task and maybe frequency, right? So if there's further away buttons, yeah. Those are going to be less frequent. You can think about this on your phone as well. Where are the buttons on the apps, right? Like on Android, the back button is always in the same place. On Apple, the back button's always also in the same place, but in a different place than Android. But the buttons are often arranged for your thumb to reach them, right? Another set of design principles is about visual search. If I give you it's going to take cognitive load. So ideally, I want to highlight things for you. And there's a whole bunch of things called Gestalt principles. Highlight things for you. And there's a whole bunch of things called Gestalt principles. You can look them up. And this is an example of a Gestalt principle where when you have things that are similar, because this is a different angle, it immediately pops out. Right? And so if I want a different angle, it immediately pops out. Right? And so if I want to get your attention, I want things to pop. Right? So there's 6 or 7 Gestalt. Right? So there's 6 or 7 Gestalt principles you can use that will show that sort of thing. Some more in the readings. Okay. All right, we're going. My aim is to go to 12:30. Is that all right? Okay, so we'll go to 12:30. We'll let you know. Here's a new topic. Okay, so we'll go to 12:30. We'll let you know. Here's a new topic. Here's a picture from Iowa. You get to divide over topics. Okay, So he will argue, and other people argue, that there is no such thing as multitasking. It's really just about swapping. And here is the list of ways that you can tell whether something can be easily swapped. So if I have a really difficult task, it might be hard to switch between that difficult task and another very difficult task. But if I have 2 easy tasks, it's easier to switch. You know, if I have a higher priority task, so these are all factors that affect how well I can switch. And there are people that try to build computational models of this and predict, oh, here's some software that my users are going to be using. Here's a pilot, and in the pilot's cockpit, here's what they're going to be doing. I have modeled all their tasks, and I can predict whether they will multitask or not. And sometimes that works, actually. These models, when you get something like a pilot in a cockpit, cockpits look complicated, but you can actually list out all the things the pilot's going to do. And it's a long list, but you can list it out. If I said do this for surgery, it's way harder. There's just too many things to list out. But so in India, do people know the story of the Goldilocks and the 3 bears? Is this a story you grew up with? I don't know. Goldilocks breaks into a house with 3 bears, and they're different sizes. And eventually she tries the beds, and she's like, "There's Daddy's bed, and it's too hard." And there's mommy's bed and it's too soft, and then the baby bed, it's like, oh, it's just right. So what people, you talk about the Goldilocks zone is when things are just right. It's not too strong. So let's think about task performance. How well am I doing on the y-axis? And task demand is how many of my resources am I using? So if I'm over here, I'm going to say your task today is to watch for bad guys that come in the door. You're going to be watching an array of 20 security cameras, but we're in a really safe neighborhood and no bad guys come in. You're going to be bored, right? So your performance is lower. So then when the bad guy finally does come, you're bored and you're not vigilant, so you're like, oh, I didn't notice the bad guy. So if you're not engaged, your performance is low. If I say you're going to watch for bad guys, and there's like 50 bad guys because it's the bad guy conference today, and they're all hoarding through the thing, you're overwhelmed, right? So your performance is going to be bad if you have too much demand. There's a video I'll skip for now. This is a video. There was a woman in the 50s in the US named Lucille Ball, who's a comedian. And in this skit, she's working in a candy factory, and the candy comes out, and it gets faster and faster, and she reacts in humorous ways. But it's a great example of cognitive load. Like she's like trying to deal with this candy. And part of what I just explained about the Goldilocks, another name for this is the red line, which is the red line is when the task demand is too big, and then you run out of resources. So you might hear people talk about, oh, we need to be in the Goldilocks zone, or you might people say you don't want a red line, like you don't want to go past, the time at which you can actually get in. Okay, so these are some videos about multitasking and how problematic it is. I'm going to skip them for now, but here's one of the key components. How many of you have had a good idea while you were maybe in the shower or like walking somewhere or running, maybe at the health club? Anyone had like a new idea? Okay, so what's going on there? What's going on is that you're not giving your brain any input. And when your brain is not getting input, it can work on consolidating ideas from your past experience and be like, oh, you had this experience, and there's this interesting puzzle you're facing at work, and it can put together things and present you with new ideas, and you're like, ah, that's great. So, there are people paid hundreds of thousands of dollars per year to keep you looking at this. Like, graduates from our programs are like sitting out in California getting paid $400,000 US a year just to keep you looking at the phone, because then that makes the company money. So it's hard to fight that force, right? And if you struggle with looking at your phone, like, it's no shame if you're like, I need extra help. I need an app to control this timing, or I need a friend to tell me to stop, right? Because there are these well-paid people fighting that, and you can't beat them alone. But my point is, if you end up on the phone too much, there will be no time for the good ideas to arrive, because you'll be feeding your head. And you don't need to feed your head so much. You need to let your head process. Here's more on the multitasking. You can have on the left side things like driving and talking, because the switching is within seconds. So there are certain tasks you can switch within seconds, and that's good. Certain tasks you can switch within hours. I'm going to cook some bread. It's going to take several hours, but I can go read a book in between. And also, it's not that urgent with the consequences. I might burn the bread a little bit, but it's okay. So you can analyze this, and Salvucci and others in the readings, there's optional reading by Salvucci, they analyze this deeply. So if you end up designing a system that involves multitasking, it's worth reading this and figuring out these factors. Forced interruptions are better. So let's think about what happens when there's interruption. I've started my first task. My first task is solving this math problem. And then I get a second task. My phone rings. And I'm like, oh. And I have an interruption lag where I have to say, like, okay, wait a minute. I'm doing the math problem. Where was I? Okay, I'm going to write down where I was. Or, maybe it just goes away. And then I start the second task. I'm talking to my mom. And then I end the secondary task. And then I've got this lag where I have to resume the first task. Where was I? Right? So when you multitask, you have these two different lags, which are adding time to your burden. So really, you want to multitask as little as possible, because in the lags, you've got wasted time, and you've got potential for error. And the other studies from NAS that shows that the people who think they are good at multitasking are often the worst. So it's like you think you're like, oh, Stephen's talking about don't multitask. It's like you think you're like, oh, Steven's talking about don't multitask, but I'm good at it because I'm young and I have a lot of coffee. It's like, no, don't do that to yourself. I'm young and I have a lot of coffee. It's like, no, don't do that to yourself. Okay. All right. All right. And then we'll take a stand-up break. Is cognitive load. So we talked about the system 2 is the part of your brain that has to work hard. And you can imagine if I give you a math problem. For the travel incident, yeah. For the travel incident, yeah. So I was on a team, like, who understands traffic, and he's like civil engineering in cars, and he does all that analysis. And I'm more the user interface person. So I was supervising the team designing the interface. And then we would test it we would go back to the TIMs and say, would you use this? Try it out for an hour. And we'd get their data, like, try it out. And they would say, like, I have no idea what this button means. And we're like, oh. Yeah, and we go redesign it. That's right. Yeah. Any other questions for lunch? Sorry.
Us not practicing enough and not getting in depth enough. So, like, how do we define it? Healthy versus unhealthy.
So there's, the healthy versus unhealthy load. So we talked about system 1 and system 2, right? So if I'm going to be a musician, I need to practice that it's automatic. And I'm at system 1. I've got automatic everything. I'm going to play this song and it's automatic. And I'm at system 1. I've got automatic everything. I'm going to play this song. It just happens. My fingers flow. But I'm trying to think of what the unhealthy would look like. You're saying unhealthy on my phone, or like I spin all day in the music?
More like somebody saying, oh, you're studying way too much. You're studying 30
playing the music.
More like somebody saying, oh, you're studying way too much. You're studying 30 hours a day. Later on, become a focus on making projects. So now there are like 4 local joints available, and then you know that they're kind of making it fresher than the tolerance.
Yeah, I haven't heard that vocal for local. Makes sense. I just like. Okay, are we ready? Ready to think about games? Okay, so we're gonna have this game analysis activity, and we're gonna try to apply some of the skills we learned earlier, or some of the ways of thinking. And I will say that what happens in my regular course that's longer is the students say, oh, I get to play a video game for class. And then by the time they're done, they're like, that was exhausting. So we're not going to get through that here just in an afternoon. But you think about how much it takes to analyze a video game. There's 2 parts to analyzing a game. There's the game itself. Like do you know Tetris? Right? Tetris has the falling blocks, and you orient them. So if you're going to analyze the game, you have to know, well, how many blocks fall per second? And when they speed up, how much do they speed up? And do they fall randomly or do they not fall randomly? Are they falling based on your situation? And so you have to figure out the algorithm of the game. And then you have to figure out how people play and come up with a model for how people play. And that's a whole separate analysis. So it's not trivial to actually analyze a game well. So in the real world, when you're doing these cognitive engineering environments, it's a lot more complicated even than that, right? If I'm analyzing a hospital emergency room, I might need to watch people for several days or longer. So the game is a good little toy thing. And so ideally, what we're going to try to do now is watch somebody play as a novice and an expert and compare their play, and try to say something about it. In a short time, we can't like collect a bunch of data and put a model to it, but you can say something like, here's what I saw. And the really fancy version, if you get to it, and what I'm hoping to do is we start today working on it, and then tomorrow's afternoon you sort of present what you did. So we got, if you want to, I was unclear on whether you're supposed to have homework or not, but if you have some time, you can work on it. And you could have a mathematical model of performance, like oh, if you're a novice and at Tetris, when the blocks are moving at this speed or above, then you're going to die. Or when, you know, this sort of thing, like a little line, right? Okay. So we're going to ask you to work in groups of 2 to 3 people, and we'll figure that out in a minute. And choose a video game. The best games for this activity are games that are single player, that have time pressure, and that are not just cognitive like chess or Sudoku, because then there's nothing about play, right? It needs to be like, and also, you know, nothing that we'd be embarrassed to see. Maybe you would never do that, but the American students would be like, oh yeah, it's all bloody and killing the people, and I'm like, no, okay, so when you're looking at the game, you might say, what are the attentional zones? If it's on your phone, maybe there's one spot on your screen that you mostly look, or maybe there's 2 spots that you always look. And when do you have to look? And then try to actually record some data from a player, like maybe one person's playing, say you're playing, tell me your name again. So Oom's playing, and then Karnish is watching and video recording him playing, and then the rest of the group is like watching the video later and counting how many moves makes per second or something like that, right? And sort of analyzing it. And so the key question is, how do novices and experts differ? And also another way to look at this is, what are possible errors? So in Tetris, there's really only, you know, you can make errors like, oh, I didn't rotate the piece right, oh no. But that's mostly it, right? I mean, maybe placement in the row, so you could have maybe a rotation error, you could have a placement error, but it's not very complicated. Where there's other games, then you can die in lots of ways. So, okay. So the output of this, what I'm hoping you can deliver tomorrow, is a 5-minute PowerPoint presentation, or slide, whatever slides you like, sort of 5-minute presentation from your group, and maybe get some game screenshots that show how you analyze the game, get some discussion about what you did, how do novices and experts differ, and then the interesting thing is, if you had a lot of money and a lot of time, what would you do, right? And that's when you say, oh, if I had 3 months to analyze this and the entire data set of, you know, the Game Boy console, I would do this, right? Okay, so here's some examples. So we have some new people. So are y'all going to play too? You're going to be part of this as well? You ready to do things? Okay. So I might summarize in a minute. Sorry?
What's human analysis versus game analysis?
So the human versus game analysis is like, let's say, have people seen this game? I should bring it up. This game, Frogger. This is like ancient. So here's Guitar Hero. This is a game like the guitar notes are coming at you. Here's Breakout. Here's Frogger. Has anyone seen Frogger? This is like from when I was a kid, right? And so you are a frog, and you're trying to go up and cross the roads, and the cars are coming, and so you have to like push your frog up at the right time. And the frog can get run over, the frog can fall off a log, and all these things. So the game analysis, to answer your question, the game analysis is like, well, how many levels are there? Okay, there's 5 levels, but maybe some are faster than others. Like level, you know, maybe there's really like 2 levels here, slow cars and fast cars. And then maybe there's a couple levels here, and you know, how fast do things move? This sort of thing. That's the game analysis. And then the human analysis is more like, okay, I watched an expert play, and they tend to move the frog about once every half a second. They seem to have these strategies, like wait for a special log, or you know, wait for a row of several cards. They have these strategies. And I watched a novice play, and they move at this rate, and they have these other strategies. Something like that. So you're analyzing the game and you're analyzing the human. Does that make sense? And I mean, I've been talking about a 5-minute PowerPoint. So this analyze can be like, you know, 150 words, just in a paragraph or something like that. It doesn't have to be deep. And I'm not grading you on this, really. So this is not like your life depends on it or anything. I would say give it, you know, a good shot, and try to impress your classmates. I don't know.
Yeah, like
Sorry?
You analyze the settings and the menu as well?
Seconds on the...
Settings and menu.
You could look at the settings if you want. Yeah. I mean, I think in the gameplay itself is what we're interested in. But is this okay so far? Doing okay? Too much? No? Okay. So I'll rehash a little bit. Here's some other games that have been analyzed. This is, I forget what this is called. Anyone know that? It's like unicorns and stars or something. This is like a Flappy Bird type of thing. This is a really weird game. I don't recommend it. It's like spinning hexagons. This is Symmetrain. You're like the train's going up. Anyone know this one? Yeah, so you're all like, oh, totally good. So this is an example of attentional zones. So they analyze the game and they say, okay, on this game, you have to look two places. You have to look, you know, mostly you look here when there's a tree limb coming. So you can look in the center of the screen. But sometimes you have to look close and far. So then they said, well, this is the overall zone, but it's got these two parts. And this is just going into more detail about things that can be hazards. So they're trying to look at where you're paying attention. But notice that you don't ever really have to look over on the sides. Here's an old Nintendo game. Okay, so for the people that just walked in, here's what we're doing. So you're going to pick a video game. So here's what I thought we should do to match groups of 2 or 3. Who thinks they are an expert at some video game that they can play right now on their phone in this room? Okay, so stand up. Anybody who's an expert, stand up and we're going to go to the wall. Who else? And it doesn't have to be like superstar prize winning expert, just better than most people. Okay, and we need, let's see, how many people we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have about 30. So we need like 8 or 9 of these people. So we need some more people who are good at a game to stand up over here. And then the people who are not as good at a game, we're going to match you with experts, and you can be the novices. So we need some more experts. Somebody who can play a game pretty well. Any game on your phone that is time-pressured, single player. Any game on your phone. Got anybody else? Everybody else is like, I don't play games. What are you looking at me for? No. You want to be over here? Okay. Okay, nobody else? In the back? No gaming in the back?
I can play game, but I need to download it first.
You can download it. Yeah, if you can get on the Wi-Fi or whatever. I mean, if you can download it. Because we're going to then play it. Like, whatever the game is, we're going to try to play it here real soon. Okay, so this is good. So now, we're going to have, we've got 8. And so we're going to count off. Are we going to match you with the students? Are you okay with that? Yeah. You want to be in your own? Okay, so you're 1, 2, you're 3, you say 4, 5, 7, 8. Now you're 1, 2, 3, 4, 5, 6, 7, 8. So remember your number and then go and stand with the person. So he's 1 and he's 8. So you now know your teams. Does this make sense? Okay, so get with your teams and then you're going to try to watch an expert play and watch a novice play and figure out your roles on the team. You might have like, oh, who's going to be the person who's going to record the data? Who's going to be the whatever? Okay. And then move around the room and you can start working and playing and analyzing. Okay, go to it. You're on.
How to make group?
So I think you were like 1 or whatever.
Yeah.
So then you would stand with the person who was number 1.
1 and 1?
Yeah, ones and ones. Who is number 1? Where's group number 1? Okay, so you already have 3. So you're 2. Who's 2? So you need to be with 2, I think. Or I don't know. Does everybody have a group? Oh, I should have numbered you on the wall. Sorry.
Experts are confused. Yeah, let's be.
Okay, so the 2s, raise your hand if you're a 2. Who else is a 2? You're a 2. We need a third 2. Who else is a 2? That's you. Okay, y'all are with him. Who's a 3? So we have 2, 2. Was there another 3? You remember who was along the wall? So are you a 3 with them? Okay, so 5's good. Who's the 6s? Okay, who's 5s? Raise your hand if you're a 5. 5s, 5s, 5s. Oh, you got 5. 6s, 7s, 8s. So what are you? 4s. Oh, go be a 4 with them. Unless you wait a minute. What are you? 3. Can you join them? Okay. Okay, I think we're good, right? Okay, go be groups. Oh, we have new people. You can find somewhere to sit if you want. Yeah. Hey, are you joining? Welcome. We're just starting an activity. How many people do we have? Okay. So what we're doing is analyzing a video game. And so what we need, I want to break you into 2 groups.
These are our undergraduate students.
Okay, great. They can do it too,
Yeah.
right? Okay.
They are presently studying ergonomics also.
Economics.
Yeah.
And industrial design. Or just economics?
Ergonomics.
Ergonomics. That's great. Okay.
Two groups, right?
Okay, so what we need, we need 2 people who are good at a video game on your phone that you can play like right now. Is there somebody who's good at a video game on your phone? Okay, you're good at that? And you?
Not good.
Who else is good? So you're good. Who else has got a game they're pretty good at that they can play right now? You don't have to be like a superstar, just like pretty good. Better than me who's like never played it.
No, I have played the games, but I am not that good. We're not good at it.
Okay.
You can call people.
Is this another new person?
Yeah.
Video games.
Okay, we got more new people. Are you good at a video game on your phone? Is there some video game?
He's good at it.
Okay, so then you 2 are going to be 2 teams, and then the rest of you follow. So I don't like you join with him. Is that all right? So y'all are a team, and then y'all are a team, and then the game should be single player, time pressure. Does this work still? Time pressure? It's got time pressure? Not like Sudoku or something. Yeah, okay. And then what we're doing for this project, and I can show you more slides if you want, but what we're doing is we're analyzing how an expert plays versus how a novice plays. And you have to analyze the game first, like how fast do things happen at this game? You know, if it were like Tetris, you know Tetris, right? So if it's Tetris, you'd say, oh, how fast do the blocks fall? And how fast do you turn them? And how fast do you lose? And like, how does the game dynamics work? And you would like do this with like a stopwatch, right? And then the other is the player. So you analyze the game, then you analyze the player. And you say, we watched an expert player. So maybe on your team, you're gonna play and he's gonna video record you playing. And then you're gonna look at the video and say, oh, he was clicking this thing every 5 times a second. Or he was doing this, you know, a bunch of times. And you sort of analyze his behavior and why and what sort of errors he makes. Like, how do you die? What are the ways you can die? And then you're gonna do the same thing for a novice. So maybe you've never played the game and you play his game and they videotape you and they compare. See what I mean? So the goal is to look at how it's different for novices and experts to play, because experts are typically not just novices that like grew up. They're like often they think really differently. Strategies, that sort of thing. Does this make some sense? Okay, let's come look at the slides briefly. Walk this way. So let me show you this. So this is an activity we're going to do now, and then it bleeds into, can you come back tomorrow at this time? Because then you can show off what you did. So the idea is that we're going to do it in yeah.
Classes doesn't clash, then obviously.
Yeah. So does it? You can come back tomorrow, like roughly 2, something like that. Okay. So we're analyzing the game, novice versus expert performance, right? If you have time, do some mathematical model, like like there's y equals mx plus b, right, for linear equations. It could be that you look at the data and you're like, hey, I think experts do this line and novices do this line, or something like that, right? If you can. It doesn't always work. 2 to 3 people. Here's the game. Single player, time pressure, not cognitive, not violent and sexual, please. And then, like, attentional demands. Here's what I mean by intentional zones. Like I forget, what's this, Tomb Chaser or something like this? Yeah, Temple Run, right. So there's attentional zones. Like you have to look here and you have to look here. So they analyze it that way after watching the play. You don't have to look on the side. So you might decide to do that. There's different games. Okay, so how frequent do you have to do things? And so you record data from one novice and one experienced player, and you write down, like, what do the players have to do? What sort of errors do they make? And how do the novices and experts differ? And then you turn that into a 5-minute presentation. And ideally, you have a video or some pictures of your game. Some people will be like, here's an expert playing, here's a novice playing, and they have a little video. And then talk about how you analyzed it, and then how the novice and expert differ. And one of the interesting things to do is then say, if I had, another 4 months and $10 million, then I would do this analysis. If I had, thousands of players from the game studio, I would do this. Does that make sense? So figure out, and so when you present, you can have one person talk for all of you in your team, or you can take turns talking, or whatever you want to do. Does that make sense?
Yes.
Okay. Go. You can do it. All right. Do you have any questions? You good? You're doing it? Okay. You might try to get him to talk while he's playing, if he can. Yes?
We have to play the game and we have to record.
I think if you play and then you record, either he can like hold his phone and record, or you can record, and then you can watch the video.
So let's say he's the expert player.
Yeah, he's the expert.
So he's playing.
Yeah.
Another one will record that.
Right.
Then we have to analyze.
That's right.
What mistake we did, what we achieved, what was the problem in that playing.
That's right. Like what are the mistakes he made? How did he die? What strategies did he have? And then you get a novice to play it and do the same analysis.
The same analysis. You have to compare them.
Yeah.
So same thing we have to repeat.
Yeah.
Another person will play.
Yeah.
Then we have to record again and we have to analyze again the same parameters.
That's right.
Then we have to compare both.
Yeah.
Okay.
Yeah.
Thank you. Sir, is this the team final for the tomorrow presentation? This is the team which we have to present tomorrow with this team?
Yeah.
And the game we have decided. And sir, could you please share PPT this part?
Could it-
Video pictures of video game on this need to have prepare the presentation for tomorrow.
Sorry, what's your question?
My question is, sir, could you please share this?
Just talk through this?
PPT.
Just talk through this?
Yeah.
Yeah.
Game
So,
analysis.
oh.
Okay. Sorry. tomorrow's PPT. For tomorrow's
Yes,
PPT,
yes.
what all things we need to include? We need to have a screenshot, we need to have a video recording.
Yeah. And it doesn't have to have video if it's too hard. But
And
and what?
what more things we need to put on?
So then
Also, I will just take a picture of it. If you don't mind.
yeah, go. Yeah. Hi. Are you joining? Okay, and then he's joining too, right? You're just joining? Oh, you're part of them. I'll leave you alone then. Okay. Do you want her on your team? Okay. So yeah, you can fill her in. Have you figured out what to do?
Huh?
Have you figured out what to do?
Currently, we are figuring out a place to sit.
Ah, I mean, they could sit out some in the hall too. I don't know.
Next room. Next room.
Next room if you want, or you could sit up at the flower table. I don't know. You know. Okay.
We'll sit in the next room.
Okay. Is this working?
Which somebody else is also gonna review.
Yeah, that's okay. Because you might analyze it differently.
Yeah.
I mean, it'll be interesting to compare.
Yeah.
You're all playing. Okay. It might be helpful if the player talks out loud while they play. It may be too distracting. You may not be able to do it. But you could see if you can talk out loud while you play. You figured y'all are a group? Okay. You okay?
Yes.
Good. Thanks for helping with the Mac. Good? Okay.
Then I will adjust my lane.
I'm gonna go check on the next room. I'm just gonna check on. Yeah. If you're bored, you could start making the 5-minute presentation. You know, start making slides.
Sir, should we play like a one single set of game and then compare it with the two novices and one expert like that kind
I
of
think that's good.
Okay,
Yeah,
so-
just like one level or something.
Okay, so we have made a video.
Okay.
So
So you've got the expert and the novices?
yeah.
Okay.
We got that.
So now I would try to analyze it.
Okay.
And you might have to get out paper and maybe somebody else's phone to use a stopwatch and start timing like how many events happen and how fast do they happen.
Okay,
and-
so like we have made the videos like this,
Yeah.
so let me show you. So this is an novel playing this game. So you have to like move the cars through a city. This is a car racing game, one versus one.
Yeah.
So you have to maneuver through the traffic. You have to maneuver through the police barricades are there.
Yeah.
So you have to maneuver it from there. You have to also protect your car from the ongoing traffic.
So maybe you can write some numbers about number of barriers per
Numbers
second.
of barriers per second. How many barriers are there? How many road turns are there?
Yeah, yeah. And maybe there's categories of problems.
Yeah.
Like you've got turns, you've got other cars, you've got
Police barricades and all that.
barricades. Yeah. And you're like, okay, there are this many barricades per second, this many turns.
Okay.
Yeah. You can just play one level and get a lot of data out of one level. You don't have to like play till you die, too. Hmm? Okay. So with Subway Surfer, you're probably going to be counting things like how many train barriers are there. Like there's categories of barriers, like train barriers, column barriers, and then there's things you got to do like coins and like how often do these happen, and you know, if you get some of that. You okay? So after you get some videos, yeah. So then start analyzing them. Like, what are the barriers? Like, what game is this? Okay, is it time pressured?
No, it's not time pressure. It's like run, and there are few buttons.
Yeah.
Control it more better. If you missed it, can you analyze it? How many times you
Yeah.
missed the
So it
button?
might work. I mean, see what you think. See what otherwise take a different game. But you would then start analyzing it. Like, well, what are the challenges? Like, see, I don't know cricket very well. If it's like Subway Surfer, it's like, well, there's trains, there's columns, and there's coins. You know.
There is another game which is a kind of targeting game, right? There are two groups. Means one side, one player will do aiming and try to kill the other person.
Uh-huh.
There are certain levels.
Yeah.
Live present.
Yeah.
Within that 5-6 shots, you will have to kill that opponent.
Yeah.
That kind of game is there.
I mean, you could also do that if it's not too bloody and gory. But I mean, this could work too if as long as there's like what is there to analyze? Like how many?
Like there are the bowling styles, how you are bowling the
Okay.
ball and how you are putting it.
Okay. And are novices going to be
Yes.
worse than experts, or can everybody bowl just fine?
No.
Okay.
The thing is that in the bowling you need to select where it will get dropped,
Okay.
where it will place.
Okay.
Otherwise it can get wide or the ball speed will reduce.
Okay.
Second, you have to select the run-up. If you not select the run-up, so your bowling will take much time.
Okay.
So in that way it is little bit time pressure.
So you're the expert here.
Yes.
Okay. No, that's good. I mean, there's enough detail here that you can analyze that.
Yes.
Okay. So that's good. So try to analyze it. So then it's like how frequently do people mess up? Why do they mess up?
Yes, because mainly during bowling, you have 3-4 buttons simultaneously. You have to select one after each.
Hmm.
If you forget, if you make it delay, so the game can be a little prolonged.
And then are there, when you have what do you call it, batter? The person who's the batter? Are there different batters who are like holding themselves differently and you have to react?
In which position he will set, he will see the ball position. Instantly he need to make the decision where he need to hit the ball.
Okay.
He need to hit the ball right.
Yeah, like I see the guy standing this way, so I do this.
Yes.
Okay, so then,
So that depends on how you, for example, if his ball is supposed to hit it at the right, if he hit it at the left, he might get out.
so then how many different configurations of batter are there?
Yes,
Are there
and
like,
how much run he has scored?
are there like 8 or 20 or 4 or Like how many different batter stances do you have to
Only
learn?
batter stances is 2.
Okay, so there's 2 of those.
Right-handed or left-handed.
Okay.
But after that, there are different types of shots. For example, in the right side, there are 5-6 types of shots. On the left, there are 5-6 types of shots. That depends where the ball is landing.
But then, so I guess I'm driving at, if there's 5 kinds of shots, do I get to pick my own, or do I pick the right one? There's like one right one out of the 5.
One will be the accurate one.
Okay.
But there are few times where for one option, you can play multiple type of shot. But the thing is, if it's not accurate one, you will have a high risk of getting out or not getting the run desired. For example, if the ball is coming short, ball is coming at this way.
Yeah.
You have to play either this way or this way. If you want to play this way, it will get out and you will get caught.
Okay.
It will hit your ball.
So this sounds like there's plenty to analyze. And I think what's interesting is if you, I mean, you've talked a lot about your sort of expertise in this, and maybe, are you the novice at this? Okay, yeah, so you're the novice. So it may be interesting to talk about, like, you've got schemas in your mind or structures in your mind that are not in his mind. And so therefore he plays this way. And if you were going to train him, like, what would you have to teach him?
So
I mean, and you could like write that down. You know?
First thing is when he's fast.
Like you don't have to tell me. I'm just telling you. Okay.
First I told him that how to play the game. What are the options?
Yeah.
But when he played, I recorded the footage. There are few buttons. I saw him miss.
Okay.
Missed the clip.
Okay.
He took more time to finish the game.
Yeah.
That is not something called. There is no penalty of it. If you take time pressure, there is no penalty. But if you take wrong shots, if it is wrong ball, either the opponent batsman will score more runs, or ultimately will lose the game.
Okay. So another way to analyze this is predicting his outcome. Yes. Like, is there a way to say, like, oh, I saw the way he did the first bowl, and based on that, I think I can predict his next 3 bowl scores or outcomes or something like that.
Here, if you first thing is you need to select the shot.
Yeah.
Second thing is you need to time the shot to get the perfect. If it is there is a green zone, if you hit the ball in the green zone, it will go to either boundary or 4 or 6. If you don't hit in the green zone, either it will get out or you will miss it.
Okay. So keep analyzing. Number of red things per minute or per second or something like that. Yeah, good.
Now we are checking with the chin of the cycle till it touches with the.
Yeah. And is he? I mean, where is he looking?
So I'm looking
up here, which you can tell by like if you play again, you can like, okay, where are you looking? Can you still play?
It's difficult.
Yeah, right. You know, right. That's the way you test where he's looking. Yeah. Okay, keep at it. Yeah. Are you all okay? Okay. One way to know where people are looking, if you have an idea and you're not sure where they're looking, then try covering up that spot. And if they're like, I can't play, then you know they were looking there, right? What's that?
We like trial and error. We really don't know where he's looking, so we are like trial and error.
Yeah, that's right. Are you all okay?
Yes.
You're trying to get a desktop game?
No, sir.
Are you going to try to do the PowerPoint? Yeah.
12.06. Second, third.
You okay?
Hello, hello.
Group. Okay. Yeah. So you're getting.
Yeah, we are recording.
from there we can just analyze the results.
Yeah.
We are recording the screen at this very time. So how we are playing, what are the touch points of the game, how are the finger movements
Yeah,
are
yeah.
important in the game. So
That's
we are
good.
tracking that also.
Okay, good. Are you going to be able to do something? I'm worried you're bored. You okay?
I'm just waiting.
Okay. Okay. Y'all doing okay? Good. You doing okay? You able to do something? Okay. Y'all okay?
Yes, sir.
Okay. Yeah, good. Okay. Y'all doing okay? So what have I've never seen the sand decorations.
So this is called Rangoli.
Aluli?
Rangoli.
Rangoli.
R-A-N-G-O-L-I.
Rangoli.
Rangoli. And we do this in front of our houses in every festivals.
Okay. And then somebody has to clean it up later with a broom?
Yes.
Okay. That's cool.
Like in some houses, they also decorate it with flowers and all.
Mm-hmm.
Like they put flowers above it. In college, they make just the Rangoli. And they also make bigger ones. Like it is a very smaller one.
Mm.
They like this room size Rangoli. Then.
Wow. How long does it take to make that?
It will take around 1 hour, 30 minutes.
Huh.
They put that Rangoli with hands.
Mm.
Like this.
Okay. It's like by hand?
By
or,
hand.
or there's like a...
No, it's a completely by hand.
Oh, no template. It's like that. Okay. Cool. I thought there might be like a laser cut template thing.
No, sir. There are stencils are coming nowadays, but like obviously, someone will know like this is made with stencil.
Yeah.
And it's very obvious designs.
Yes. Okay.
But by hand, it looks better.
Yeah. Good.
So it is a fine sand and color
Yeah.
sand.
Yeah, that's cool. Hey. Hmm?
We two have played it. He's playing.
Okay.
He's the expert.
So do you want to hit the balls or you want to avoid the balls?
We want to hit the circle ones and
Yeah.
avoid all the square ones.
Oh my goodness. That's
But-
hard.
And it's also, and you can't skip any circle. If you will skip circle, you will lose.
Okay. Wow.
And for me, like initially circles, I'm even confused with circle and looking, it's coming when it's coming fast.
Yeah. That's really hard. So that's about, that's a hard visual, it's a visual load. We talked about the VACP in class, visual attentional load. Yeah, if you want to talk about that. Oh. So some of you might be interested in trying to use this cognitive load thing, this cognitive load scale of the different kinds of mental workload. Some of you weren't here earlier, but this is a way to rate. Like if I just ask you to notice if there's a red light, you can be like, oh yeah, there's a red light. And that's low on the visual load. It's easy to do. But if I ask you to distinguish between 3 red lights, one's triangular, one's round, and one's square, that's a little harder. If I ask you to distinguish these subtle colors of red, it's even harder. So I don't know if this is useful in your game, but it might be. Just an idea. Sorry?
Tutorial over?
I think they're, no, it's not over. I mean, they're
doing analyzing.
Yeah, they're doing analyzing. And I figured we'd go till 4, and then I say go home and come back tomorrow with your results. Or what do you think?
What? I'm not getting what?
So I thought we would end at 4
Okay.
today. And then I say tomorrow at the 2 o'clock tutorial, come back and show off your results.
Okay, that is fine.
Is that
But,
okay?
we can extend, no problem. Because morning we took little bit less. No? So we have to cut that video and we have to send them.
So I didn't know if it's okay to have them do homework and they're working tonight, or they don't want to do that.
Huh?
Can they work on this tonight?
Yeah, fine. You can allow them.
Yeah.
You can ask them to do, they will do.
Okay.
And tomorrow they can present.
And I could see if anybody's like ready to present
Yeah.
today. You know, I'll be like, hey, is anybody ready to present? Hey, you're back. Yeah, there's you might be interested in this too. It's a slide about analyzing cognitive load, and so it might help on your game analysis. How's your PowerPoint? You're making notes. Okay. How are your slides? Are you going to be like, we're almost done? No, that's fine. Just checking. Okay. So tomorrow, for like tomorrow's tutorial, I thought we'd spend about an hour. Everybody shows off their presentations.
Okay.
And then the next hour, we'd do a new activity.
Oh.
That's right?
Okay. Yeah.
Hmm?
We need to make it now and present it today, or we need to make it tomorrow?
Well, we want to present it tomorrow, so you can make it now or tonight or whenever. What is your?
Now you can present.
Yeah, you can present now if you want.
We have to first analyze it, we have to take out
Right.
sketch.
Now you analyze. In room you cannot analyze. No? So you can.
Let me just change this to or. If it's too hard to have video, you don't have to have video. Yeah.
I wanted to ask the difference between visually discriminate and visually inspect.
Yeah, so discriminate is more like I'm asking you to look, is there a blue dot or a red dot?
Okay.
And then inspect is more like I've got 6 blue dots and one of them has a special triangle on top, and you've got to see multiple things and pick one out. That's like the inspect. It's subtle. Yeah. So if I want everybody to show a presentation tomorrow, what's the best way to do that mechanically with the laptops and all that? Like, should they all upload them somewhere?
Yes.
Or,
They will upload in one drive, pen drive.
okay.
One pen drive will connect.
Okay. So like somebody.
One they will, the group may present.
Okay. Is that something we should tell them about today? Like, here's the one drive.
Tomorrow we'll collect in the morning, because afternoon they will give presentation.
Okay.
So morning we will collect.
Okay. Okay. Good. And I should make a slide. I can do this tomorrow morning too. Well, no, I should do it now. I'm going to plug in the cable again, the Ethernet LAN cable, because then I can make and then I can show them the.
Do you want LAN cable?
Yeah, let's try that. And then you can log me in. Does the LAN cable work or no?
Sir, like I can connect the Wi-Fi. It's there.
Oh, the Wi-Fi? Sure. Yeah.
It's the first one.
First one?
Yes, sir.
Let's see if it's happy. Okay, nice.
Game?
And so then.
Connected.
आपका कर दो फिर। ये सर मेरा वाला है।
हाँ?
ये मेरा वाला था।
मेरा वाला
आपका
कहाँ
लगा हुआ है?
तो
वो अभी मैं निकाल दिया। चार्ज में। पहले दिखाया था सर। फिर बिल्कुल नहीं दिखाया। बीच में लगा तो मैं निकाल दिया। एक लगा तो दूसरा।
कौन सा तुम्हारा दूसरा है क्या ये?
मेरा वाला है सर। अभी चार्जिंग यहीं पे रख दूँगा इसको यूज कर लेंगे। इसको लगा देंगे।
एक्चुअली बाकी लोगों को चाहिए तो वो एक्चुअली ओपन है ना, इसलिए मैं उसको भी लगा के रखा। मैं
अच्छा उसको मैं लगा देता हूँ सर, वो उस तरफ स्लॉट है पॉइंटेड
मैं एक लैन केबल है कि नहीं? मैं
लैन केबल है सर, उसके लिए है, इसके लिए लैन केबल है मेरे सफिशिएंट।
ठीक, लैन केबल चाहिए तो मुझे बोल देना, ठीक है? Is working now?
Yeah, this is good. So here's my folder of stuff. So I was going to I'll make a QR code for that, and then they can scan it, and then they can get the PowerPoints if they want. And so here's readings. And so I'll put lecture 1. Oh, I need to make a version of lecture 2 that hasn't had videos in it. Where's lecture 2? Here it is.
what is evaluation and judgment in cognitive?
So that's like, so cognitive is like just in my head, right? And then, so maybe the sign signal recognition, that's like, do you see the word hello on the screen? Evaluation and judgment might be like, which of these two, I see on my screen two meals, which one has more food? Like I have to decide or something like that.
There are two different things and I have to choose one.
Yeah, that sort of thing in my head. Or maybe trying to do some math, like is 4 plus 5 bigger or is 11 minus 2 bigger? Something like that. Yeah.
Thank you, sir.
Yeah. Oh. So if you want to use that, this is everything I've been showing you. You can find in this, it's PDFs of articles, but also the slides. Do you want to tell your friends in the other room too about that? Or I don't know. Okay. This goes to the overview, and in the middle of the overview there's a link. Are you with me all week here?
I'm with you this whole 5 days.
Oh, awesome.
Actually, I'm fourth year from this branch only.
Oh, okay.
I'm in the fourth year.
That's great. What's your name?
My name is Shubham.
Sur?
Shubham. Shubham. Shubham.
Subhama.
Shubham.
Cool. Nice. Glad nice camera. Yeah, I mean, it's got a lot of lenses and everything. It's cool.
Actually, we have 3 cameras here now.
Yeah. Should I take this off, by the way? we'll hear what you got. I encourage you to practice your talk. You can have one person talk for 5 minutes, or you can, like, you know, a couple people talk for a minute or so. If you're going to do the couple people talk for a minute or so, it's good to rehearse because you'll mess it up and go over time. But, yeah.
Is it like a hard time? Like at 5 minutes to stop us?
At 5 minutes, I'll stand up. And then you'll feel a slight threat to start finishing up.
All right.
Yeah. I'll give you like a 1 minute warning.
What are the things that we need to analyze in the video?
In the presentation?
Yes.
Yeah, let me put that slide up here. Hold on. Cool. You good? Okay. Yeah, I think I'm good. Here's the thing.